So how should we actually determine the quadratic function in given the loads as well as the y-intercept? So what is the general form of the quadratic function? It is given as f of x is equal, should be ax squared plus bx and plus c, or else you can have it as y is equal to ax squared plus bx and plus c. This is the general form of the quadratic function, where now we'll have this as the y-intercept, where the graph passes through the y-axis, and this is also the constant, which is the coefficient of actually x squared, and it is the one that determines whether the graph should have to concave downwards or should have to concave actually upwards. So take note of that. So let's say we have been given the loads as well as the y-intercept. How should we be able to deduce the quadratic equation? It should be a quadratic function if that's the case. Let's say we have the roots of the quadratic actually equation being given as, let's say, x is equal to, and the also x is equal to negative, let's say 2, and let's say the graph is having the y-intercept given as, should be, the graph is having the y-intercept, there should be this now. Let's say the graph is said to pass through, let's say, a point, a 5, let's say 6. So in this case, the y-intercept for this case will be given as, should be actually 6, which means the c is given as 6, and that for this point. So now, what is the principle behind? We know that the graph quadratic actually a function is given as f of x is equal to ax squared plus bx and plus c. So now, first thing we should have to actually come up with a quadratic function. It should be a quadratic function with these just roots. The way we discussed it before, and how can be able to come up with a quadratic actually equation given the roots, also be the same principle at first. So take note of that. So which means we have x is equal to, that is the same as x minus 2 is equal to 0. And x is equal to negative 2, it is the same as x plus 2 is equal to 0. So in this case we'll have it as, now have it in this case now. That will be given as, now we'll have it as f of x, and the being given as x minus 2 into times x plus 2. So that is, let's now have it as f of x, now being given as x squared, and plus 2x, that should be that, and minus 2x, that should be minus 4. So now have it as f of x is equal to x squared minus 4. So we have that one. Now as you can see, we have the y-intercept given as negative 4, but of which we are told that the graph has passes through the point 5,6, where the y-intercept is no longer 4 but is given as 6. How do you think you should have to go for that one? So now, reaching that far, we should have to multiply. So reaching that far, we should have to multiply a constant, whichever the constant, but let's hope you have the constant given as a. So we should have to, let me just have to transfer this. That should be up here. So in this case, we should have to transfer. We should have to multiply this one by constant a. So now, which means we'll have f of x is given as, now should be ax squared and then minus 4a, where this y-intercept will be equal to this one. So now we'll have it as negative 4a is equal to 6. Therefore, have a being given as a 6 over negative 4, of which this is the same as 3 over negative 2. So that is the value of a. Then we only have to substitute for a in this function. So now which means we'll have it as f of x is equal to 3 over negative 2 x squared, and I'll have it as negative 4 times 3 over negative 2. Now we should have it as this case. And we should have it in this case. Now have it as should be a 3 over negative 2x squared and that plus 6. Now this is the quadratic for actually a function of interest. So now since the value of a is negative, it means the graph is a concave downwards, as we already discussed about that one. So take note of that. Now what if this is the case? Let's say we have the loss given as, let's say, x is equal to negative 6 and x is equal to, let's say, 2. And given that the graph has passed through the point, let's say negative 2, let's say 12. So it should be that. So what is the actually a function, quadratic function, corresponding to this information? So now principle means the same. We'll have f of x being given as, now we'll have it as x, a plus 6 times, it should be x minus 2. And of course you can just have to say times constant a. So it can be that, which is the same as, now a constant a, now have it as x squared minus 2x, and plus 6x minus 12. So have that and as that. So which means a constant a times x squared plus 4x and then minus 12 in that way. So which means we'll have it as x squared and that plus 4ax, and that should be minus 12a. Now have that and as f of x, of which this is the actually y-intercept. We'll have to equate that one now with this one. This is 12. So have it as that. So which means a is given as the negative 1. Now come back onward to substitute that.